Okay, this is a time series analysis using the software called NZgrapher. If you type NZgrapher into Google, you'll be able to get to the program. When the program first starts up, it'll start up with a program with a data set called baby CSV. The data is on the left hand side. We're not interested in that, we're interested in the time series for this demonstration. And the time series I'm having a look at, all these TS ones are time series examples. I'm going to look at the CIS one up, the 2019 one here. I've clicked on that, the data is going to turn up on the left hand side. The first column of data is going to be the months and year, so 1990 month 1, so it's January. The amount of ice was 14,783 square kilometres of ice in the Arctic. In the Antarctic it was 4,867. So that's the data. And now we want to do some time series analysis. So the first thing I'm going to do is go and find a time series sequence down the bottom here, and I'll click time series. Now over here it'll come up with an error, and the reason for that error is because I haven't put any variables in yet. So the first variable I'm going to put in is date. That's going to be on the x-axis, and on the y-axis I'm going to have Antarctic, and that's going to be my series that I'm going to investigate. So there is the graph. Now what I can do is have a look and see if there's any long-term trends in the data. We can see by clicking there, we'll get some information about long-term trends. Good luck. And here it is. So this is a graph that I could use for an assignment or for an analysis and write in a report. So I'll save this image, and I'll call it, let me see where I'm going to put it, time series, Camtasia Visuals, I'll call it trend line. Where am I saving that? Time series, Camtasia Videos. Okay, that's good. Choose save. And I'm going to then go and do some other analysis as well, which I'll be able to use in a report. So if I click on time series over here, I'll build other graphs that I'll be able to use. There's another thing here that I should have done really, which is put a title in. Ice area of Antarctica. Date is on the x-axis, y-axis is area, and I'll have it as square kilometres like that, and the rest is okay. If I can update the graph, and that looks a bit better. Well, it will look a little bit better than the other graph. So you can see from the trend line that it's pretty horizontal, and when I click on the line it points to the data point that's actually on the line. This is 5 years, so we can see there's 1, 2, 3, 4, 5 peaks, so it looks like it's got a pattern, a seasonal pattern. One pattern for each year. We'll be able to look into that a bit more detail in just a minute. If we click on the grid lines, we can add in some comments that may or may not, more accurate. We can sort of actually say what values are there. It's a bit easier with the lines. We can go across with the lines and work out exactly what the height of the line is at a certain point. So I better save that again. So I'll just right click, save images, and I'm going to use the same name that I just used because this is a better version of it. Ice Trends PNG, save, overwrite, yes. Okay, now I'm going to go to a few other time series graphs. I'll put them down here a bit. I can do a seasonal effects graph. It's just loading. My seasonal effects graph is going to tell me whether or not my, how true it is that there are seasonal effects. That means how true is it that every September there's going to be a lot of ice, and every February there is not a lot less ice, and everything in between is on a pretty straight line. So in this case we can see that every year is plotted on this graph, and they follow each other very well. So there is evidence of a seasonal pattern here, and so that will be a good graph to save for our report writing. So I'll write it as seasonal analysis, and that'll do it. Now we've already identified that there is a linear pattern, a straight line acrossways. We've also probably identified too that in that first instance that there was no seasonal long-term cycles in there that we could see either. And in this graph here we can see the blue line indicates that there is no seasonal, no long-term cycles in there. There's no annual cycle that gets repeated. So we've got no 10-year cycle, 20-year cycle, that sort of thing. We do have an annual cycle, and in our second seasonal graph we can see that that's very clear. The pattern doesn't change very much, and more importantly, down the bottom in the residuals, this is the difference between our observed values, which are over in the table, and what we would expect to get from a model that we would be using for prediction. So if we have a look at the residuals, we might see the odd spike here. So at this particular instance in time, which was October 2005, there's a little spike, and that spike is actually just saying that the value that we predicted for that particular moment was a little bit higher than what was actually expected. So the expected line is on 0, so in that instance we're a little bit higher. We're a little bit higher again at this point in December 2007. We're quite high, and so that, which means that there was a lot more ice than we expected. And down here there's a lot less ice than we expected, and that's December 2016. So there must have been some anomaly or reason for that. It's not a very big difference, but a little difference. So, and that's in 2016 in November. So again, we need to save that graph, save the image, and go away, and we'll call that ice reconstructed, and we'll use that graph a bit later. And we've got one other graph here which we can use, which is a time series graph, which is the forecasting graph. So we've got 1, 2, 3, 4 graphs, so that's it. And those are all the graphs we have, and we'd use those graphs as our analysis. We have to write about them. Okay, this graph here, the red part is the future, so it's used for forecasting. So we've got existing graph data, which has proved to be very reliable, and we have extended that with the red line, and we can predict, for example, what we would expect to see in 2020 in that year. So we'd be able to use this part here for that purpose. So our forecast for forecast values would be here as well. So this would be 2019 in September. This one here would be, if I can get it, there we go, 2020 in October. So these are the predictions for how much ice there would be in Antarctica at that time. So as usual, we will save the image as, and we'll go and call it forecast. So I've got 4 graphs now that I can use. There is one other thing that I can use down here, which might be of use, which is the forecast output, this one here, the top one. And this is a table of the predicted value and the range within which we would expect that prediction to be. So that table could be useful for you to predict. It's particularly useful because we've got the future prediction. So we've got December 2020. We expect there to be 9.2965 thousand square kilometres of ice in Antarctica, and so on. That's how we would read it. So this table would be worth capturing or saving. We could probably copy that and put it directly into our report somewhere, probably in a at the end of our report in the data section, as an appendix, probably. Yeah, so that's how we would get our information out of Grapher. Our next step would be to use that information and put it into a report.